colleagues, your seniors who are working in that industry, try to find out which are the variables which you should take care in your study, right? Otherwise, what will happen? You will take, okay, let me do this or let me do that, and your results will not be significant. You will not get any good results out of your research, right? And as we progresses, you will understand like why I am talking about this point today. The importance of doing little bit of research about the sector industry where you are going to carry out your internship. So let's say this I did in the beginning last 2 years back when COVID happened during that March 2019, right? So let's say one of my research objective is to project was to understand the hand washing behavior in college student in time of recent epidemic threat of COVID-19, right? That was long back, 2 years back, right? Right now, if I carry out this study, objective might be different, right? If you remember, in the beginning of the COVID, lot of commercials used to come that showing that how to wash your hand, how many seconds you should wash your hand, how many number of times you should wash your hand, right? So I wanted to understand whether that really is happening or that the commercials or whatever government announcements are going, whether that has really has impact on those. And I want to study the college student, right? Whether that commercials, advertisement, information has any impact on those college student, right? Had that able to change the behavior of college students. So there are some of my research objectives. So for each of you, if you are carrying out your summer internship project, you will start with a project objective. Then divide that into several research objectives, right? In my case, I have divided into 7 research objectives, right? There is no ideal number. So if you ask me the question, how many research objectives I should take, there is no ideal number. 5 to 7 is a good number. It can be three also, it can be 10 also. If you are doing a solid three research objectives, which has a great potential, that is also okay. But if you think that okay, some of them you will not get good result, take little bit high, right? But there is no like kind of written like kind of formula that okay, you should take that this many minimum research objectives, right? Depending upon what you are studying, it can be one also, right? Your project can be one or two, but depending upon what you are studying, it can be three or four also, right? So you should take minimum research objectives for each of your project.
Recording stopped. Recording in progress.
Sorry, I got disconnected. So I was talking about how your project objective need to be divided into research objectives, right? So basically, you divide your like high level objective into different components, right? Then for each of the research objective, find out what kind of information you are going to collect. If I talk about my first research objective, whether males and females differ in their hand washing behavior. So what kind of information I want to collect? I want to collect about the gender information from the respondent who are going to respond to my questions. Then the hand washing behavior. How I define the hand washing behavior? Again, depending upon different research objectives, that will differ, right? What I've told, average number of times someone washes their hands per day, right? In a day, how many times they're on an average washing their hand, right? So that need to be defined in your questionnaire, right? Because when I say that, okay, how many times you wash your hand, whether it is per day, per week, per month, I have to define, right? On an average. So for each of your research, and sometimes it might be repeated, right? Like in my second research objective, whether different income groups differ in their hand washing behavior. So one of my variable is income group. Second variable is hand washing behavior, which I have already considered in my first research objective. So for each of your research objective, find out that what kind of variables you are trying to collect data on, right? So once you have listed down those variables, right? Okay, gender is one variable which I need to collect data on. Hand washing behavior is another variable. Income group is another variable. Time spent in hand washing per wash, right? How many seconds, right? They take time to wash their hands. So that is another variable. Then exposure to advertisement. How many advertisement they have seen in the last 2 weeks or 3 weeks, right? I have put 2 weeks. So these are certain variables I'm trying to get my collect data on, right? And from that variable, you will create your questionnaire. Don't jump into questionnaire, then think about objective, then think about data analysis. First, think about your objective. From your objective, your variables, from your variables, what kind of questions you want to create for your research. So, because I want to understand about the age, what is the relationship between age and number of times people wash their hands in a day, right? So, if I want to find that relationship, age is one variable I want to collect data. So, what is your age? Then define how you are going to ask that question. Variable is age. On which scale I am going to ask that question? I can ask the question which age group you belong to, right? Then I'll say that okay, below 20, 20 to 40, above 40, right? Three age groups. But here if you see, I want to find the relationship between age and number of times, right? As you practice, you'll come to know that which kind of scale you want to put that question on. Because if I had put that question in a, let's say, group wise, I cannot find a correlation. There are other ways, but I'm not finding parametric correlation between the two variables, right? So these you need to be careful where you are framing questionnaire. Most of the times I've seen students, they create questionnaire, then they realize that they have done a mistake after data collection. They have not collected the information, which information they need for their like kind of research project. Similarly, please specify your gender. Variable is gender, nominal scale, because gender, obviously, most of the times gender will be in nominal scale only for the identification, right? So like that, for each of the question you write down. Then final stage is obviously either Google form or physically if you're going to create a survey and collect data, write down in a Word document or take print out. Or if you're sending through Google, like kind of any kind of survey platform, whether SurveyMonkey, Qualtrics or Google Form, try to use that platform. But the point is, do not start creating a questionnaire unless you have the clarity on your research objective and clarity on the variables, right? Once you have questions, then you decide on how many sample size depending upon the population, depending upon your alpha and all those things. You calculate sample size, then send that. So if let's say I need to get data on 70 or 100 respondent, at least 3 times of that, because most of the times people do not answer survey. So 2 to 3 times. If I want to collect data from 100 respondents, send that at least to 200 or 300 participants, so that with a 40% ratio, you'll be able to get at least decent 100 or 120 respondents or answers. Once you collect data, then the next point is what kind of case you want to carry out, right? So for my first question, it was a 2 sample details. For my second question, it was ANOVA. Next 2 questions, 1 sample details, then cross tabulation, correlation, bivariate, right? So, but I have just to like demonstrate in the class, I have used different type of data analysis, not necessarily that you have to use all of them in your research project. If you are using two or three, that is good enough, right? But you should know that what kind of data analysis you have to use. How to know that? So that is where I have shared you the document, which will be helpful for you. First, find out how many variables for that research objective. Are you starting one variable, two variable, or multiple variables, right? So in the research objective, what you have written down, first find out what kind of. So let's say for my this research objective one, when I say that whether males and females differ in their hand washing behavior, how many variables I have?
Two variables.
You have one gender, one variable, then hand washing behavior is another variable. So this is where you will carry out a bivariate study, right? So this document will help you. Okay, I have two variables. Then what? Then you'll go back and study whether males and female differ, right? So there is a difference, right? So they are not same. There is a difference in their hand washing behavior. So you have to compare them, right? So there are different type of analysis, different type of data analysis or hypothesis testing method to find relationship, dependency, comparison. Comparison means where you want to find the differences. Because if I say that, okay, whom of you have scored good marks, right? I'm basically comparing, right? Somebody has scored 82, somebody has scored 67, then I compare the marks, right? If I want to understand the difference, I have to compare something, right? Compare the variables. Then out of this, find out that, okay, which is your research objective, whether you want to find relationship, dependency, comparison, then comparison between how many groups. Then you go and find out that, okay, so I have asked whether there is a difference in gender. Under gender, how many groups? Because I have only created male and female, right? So between two groups, let's say I had created whether there is a difference between hand washing behavior in different income groups or different cities they live in, tier 1, tier 2, tier 3 cities. Then there are more than two groups. So whenever you have more than two groups, there are different analysis. We have to use ANOVA. If you have between two groups, we have to use two sample t-test, right? If I want to find the relationship, right? If you remember, we are not only interested in comparing, we want to find out how these variables, independent variables, are related to dependent variable, right? Then I'll carry out a certain kind of regression, right? Bivariate regression or multivariate regression. But the point is, this part of your kind of research objective need to be clear before you jump into data analysis, right? And this is where I have told you, like for your solving problems, for your exam point of view or for your class point of view, I would have given you objective, right? So what happens? Find out number of variables and type of variables. Find out the study aim from hypothesis, right? Frame your hypothesis. For each of the question which is of 10 marks, 2 marks compulsorily will be about writing the hypothesis correctly. Because balance 8 marks, I know that if a few of you are able to kind of carry out the analysis, others somehow will find the answers. But the first two, like writing that hypothesis, need to be like from your end. And you will see that how difficult it will be like once you do not have clarity on this, right? From research objective to hypothesis. So once you frame your hypothesis, then select the appropriate data analysis method. This document I have shared with you. Just sequentially go. How many variables? What is my study aim? What kind of variable types? What is my dependent variable? What is my independent variable? Then accordingly your data analysis method, right? So this is going to help you to find out what kind of analysis method you want to use, either for your exam point of view or for your whatever later on if you do use it in internship project. Additional steps in your internship project will be, first you have to find out two secondary research, talk to your manager, do some search on Google to find out your research objectives. Convert research objective to hypothesis, alternate and null. So for each of the research objectives, you have to write your alternate and null hypothesis. Decide on scale type, because here for your exam point of view, you are not going to create any questionnaire. But for your internship, based on your research objective, based on the variables, you have to create a questionnaire. Collect data, clean data, then data analysis, then insights. From the data analysis, what kind of insights you are getting. So these are the steps you have to follow for your internship. For your exam point of view, obviously I'm going to give you the data, I'm going to give you the objective. You have to write down the hypothesis, you have to step by step, and that is something, like I said, that is important. So if you just, okay, this is the question, I will do ANOVA. How did you So you have to explain to me why ANOVA, why not other data analysis method. So you have to write down clearly the steps where you arrived that, okay, based on these steps or based in this logic, I decided that for this kind of data, for this kind of research objective, this will be a ANOVA or this will be a regression or cross tabulation, whatever data analysis you do. That logic need to be mentioned in your document, exam document. If that is not there, I'm not going to give you any mark. Because the analysis part, all of you know, I also know how you get that answer. I'm not at all interested in that. I'm interested whether you understand how to carry out that analysis, right? Whether you have a basic understanding that, okay, this kind of data set is there. I have to use a cross tabulation or a regression or something else, right? So that logic, how you find out, that is much more important, and this document will help you to decide on that logic, right? Decide on that steps. Any questions or any doubt on up to this point?
So when we use cross tabulation means what we do in cross tabulation?
We try to find out relationship between two categorical variables. So I have a two variables, bivariate, and my study aim is to find out relationship, right? Let's say I have this hand washing behavior. I have collected age groups rather than asking individual age. I have asked student which age group they belong to, between less than 20, 20 to 40, above 40, right? Then I have asked also their hand washing behavior in number of times, in a like not in a range, not in a particular absolute number. I have asked in which please mention which of the following is true for you. I wash my hands this number of times, less than 5 times in a day, 5 to 10 times, above 10 times. So there are three groups. Hand washing behavior in three groups, your age in three groups. So both of them are categorical variables. And if I want to find a relationship, is there a relationship between age and your hand washing behavior? And I have collected data on categorical. So my dependent variable is my hand washing behavior. That is categorical. How many times they wash their hand, which group they belong to, less than 5 times, 5 to 10 times, above 10 times. Then my independent variable, which is age, which is not in my control, that is independent of me, right? So that also I have asked in a group. I have asked which age group you belong to, less than 20, 20 to 40, above 40. So both of my dependent and independent variables are categorical, and I am trying to find the relationship between them. My research objective is to find the relationship between them. Then in that case, I'll go with a cross tabulation. But let's say I have asked both of them in metric, that means ratio scale. Please mention your age in completed number of years, right? So somebody will say 21, somebody will say 23, somebody will say 18, like that. Students will mention their age. Same thing I will also mention. My other question is, please mention on an average per day how many times you wash your hand. Some of them will tell 5, some 7, some 10, like that. Different people have mentioned different numbers. So there what happens, how I'm collecting my data in questionnaire, both of them are ratio, right? So how many times somebody washes their hand and what is their age, right? Both of them are kind of continuous scale, right? Not categorical, that is continuous, right? So in that case, or metric, the other name of continuous is metric data. So when I want to find a relationship, right? Both of them metric, same question, objective remains same, objective to find out relationship. But what has changed? How am I framing my questionnaire? In one questionnaire type, I have asked both the question in category, right? Which age group you belong to, which hand washing behavioral group you belong to, less than 5, 5 to 10, or more than 10. In the other type of questionnaire, I am just directly asking, please mention your age in completed number of years. Please mention on an average how many times you wash your hands, right? So I'm getting a metric data, right? So in that case, I can do a correlation. So whenever I have a research objective to find relationship between two variables, dependent and independent, depending upon how I have written down my questionnaire, I have two options, cross tabulation and correlation, right? So that's why I told that framing a questionnaire is very important. Imagine a scenario, you have asked the age group and you have asked the number of times somebody is washing their hand. Directly, there is no way where you can measure the relationship between a continuous variable and categorical variable. There are ways, but not listed here. So then you have to do some data conversion. So you have to change your continuous variable to a categorical variable, right? So the point is you have to be clear, like based on your research objective, how you are going to ask your question, right? Before framing a questionnaire, you have to see here, right? See this document and see that whether I'm asking my questions correctly. Because if you do that mistake later on, correcting that will be very much difficult. Any questions or any doubt? Because I'm not discussing this in detail, because each time whenever we do the carry out the particular data analysis, right, we are going to come back to this document and discuss that particular data analysis. But overall, whatever we are going to cover is summarized in this document.
Sir, if the dependent is categorical and independent is metric, then which type of test we are going to do?
What do you want to find out?
So here we have only three combinations, like metric and categorical for dependent and independent. And if we have categorical as dependent and the metric as independent, which type of test we are going to use?
But again, you have to tell what is your research objective, right? So your type of test will depend upon what is your research objective. Is it for comparison? Is it for relationship? What do you want to find out?
Okay, in comparison.
So in comparison, if you are telling about, okay, my dependent is categorical, my independent is like metric, right? ANOVA is there, right? So here you go that, okay, my dependent is metric and my independent is categorical. You can convert that actually. If you have a continuous variable, actually you can convert it into a categorical. If you have a categorical variable, other way around is not possible. If you have collected data in categorical, you cannot convert that into continuous, because whenever you have continuous data, you can, or metric data, you can convert that into categorical and carry out the analysis. So like I said, whenever like kind of you have a doubt, go through this document. But first point is that find out what is your objective, right? Either for your exam point of question or your like kind of research, right? So I'm not telling these are the only things. Yeah.
Sir, two-way ANOVA without replication, two-way ANOVA with replication. That so what is that?
Yeah, we'll discuss that. We have not discussed ANOVA, right?
Okay, sir.
So basically, whenever you have group and you are repeating certain, let's say, anyhow, I'll discuss that example. But because you asked, let me clarify that what is replication with replication. Replication means replications. The common understanding is repeating, right? So whenever I have two different variables, let's say I want to understand how people are performing in these online classes across different schools, right? In KIT, we have around 23-25 different colleges, schools, right? So if I want to understand how people are performing across different schools, right? So one of my variable can be difference across different schools. So let's say I want to compare School of Management, School of Rural Management, and School of Computer Science. These are the three schools I have taken, right? So in that case, what happens? My independent variable becomes categorical, right? So School of Computer Science is one label, School of Management is one label, School of Rural Management is another label. What is my dependent variable? I believe that depending upon that school, their exam performance varies, right? So whatever CGPA in term or whatever the last exam they gave, whatever scores on an average students are getting. So I'll randomly select 50 students from each school, see their what is their CGPA and accordingly take that number, right? So my dependent variable is their exam performance, right? Independent variable is category. So here I'm just taking one category, right? So what is that category? The type of school. School of Management, School of Rural Management, School of, let's say, Computer Science is another. So for my category, there are three groups: School of Management, Rural Management, School of Computer Science. So this is where I have one category. Same thing where I have two categories. I also want to understand whether the type of, let's say right now we are both offline and online. I also want to understand whether offline and online classes have an impact on the exam performance also, along with your type of school. So now what happens? I look into two categories. One is type of school, another is online classes and offline classes. So whenever you have multiple categories, so we have two categories. One is type of school and multiple categories. And I believe there is no interaction. So both are independent of each other. That means type of school and let's say online or offline, the mode of education, both are not interacting with each other, right? In that case, we are going to do ANOVA without replication. That means I'm not going to repeat the data collection, repeat the sample collection, right? So I'll collect only one sample and that is done. But when I believe, depending upon who is teaching the classes, which college, which campus, and which type of class, online or offline, there is an interaction. So what is that interaction? I'll show you in detail. But interaction means both the variables together has an impact, right? So if there is an interaction, then I have to do a study called 2 ANOVA with replication, where I have to collect multiple samples, right? So that is how the both varies. Clear?
Yes, sir.
Anyhow, we will discuss ANOVA in detail. So the benefit of again so there are different methods also. So I'm not telling these are the only methods which you should learn. Additionally, there are various non-parametric methods. There are different types of regression also. If you find time, you are free to learn that, which will help you later on. But at least these are the basic things. If you know, you can carry out a good intensive, good project anywhere, right? That doesn't mean that you should not learn other techniques. There are a lot of other techniques like how to let's say if I want to understand where I have multiple dependent variables and multiple independent variables, right? So what kind of data analysis? So there are different data. So here if you see, there are no method where it says multiple dependent variable, right? Every time we are taking only one dependent variable and multiple independent variable. In our regression also, think about regression. So as of now, what we have studied, we have one dependent variable and we are taking multiple independent variables. But if I say no, take multiple dependent variables also, is there a method? Yes, there are there. But at least, so that is again becomes a little bit more complex. But as long as you have an understanding of that, you can switch or you can learn the other techniques also, right? So these are the basic things at least we should have an understanding to carry out our data analysis, right? So anyhow, don't worry about this. We'll come back. Each class will spend some time depending upon what kind of data analysis we're going to cover, right? So quickly, let us jump into the Excel file what I've shared with you. Let me open that first. Okay. So this is the file I had. Where is this? Okay. So I put this in Google Classroom. If some of you have not downloaded this, please download this, right? So we are going to go step by step. Let's say this is my exam question, right? Or this is data somebody has given in your company, right? And we will take the same research objective what we discussed in our earlier classes. So find out whether average tuition fees annual in India for higher education is greater than 361,975. I have told you why did I taking this number. So that newspaper article I had showed you, right? So I have done some secondary research and I have got this number. So that is what is my research objective. Find out whether average tuition fees is greater than 361,975, right? So if I'm asking this question for your exam, exactly it will be like this. Data points will be given, research objective will be given. So question will be write down your alternate and null hypothesis, 2 marks, carry out appropriate data analysis and provide your insights, right? So I'm not going to write you that carry out regression here, carry out ANOVA here or carry out cross tabulation here. That is something which is important. That is something which you have to practice from today onwards so that by your exam comes or summer internship comes, no matter who is giving you the data, you know that what kind of data analysis you can do, right? So that is like, for me, the overall objective is to make sure that you understand that concept that, okay, given a data, what kind of data analysis you are going to carry out, right? So what are the steps? So like I said, I'll be much more interested rather than your data analysis, anyhow, which you are going to copy or most of you are going to copy. I'm much more interested in how you put that logic that, okay, what kind of data analysis I am going to carry out. So obviously before carrying out your data analysis, first you have to write down your alternate and null hypothesis, right? So this part already you have discussed. Can anybody quickly tell me what will be my alternate hypothesis?
The average tuition fees is
Average
less
tuition
than
fees.
it is 3,61,000
Average tuition fees.
is less than the 3,61,000.
That is my alternate hypothesis.
No, this is
It's
null
greater
hypothesis.
than.
It is greater than, it is alternative, and it is less than, there's a null hypothesis.
Yes, the null is less.
Less than is null hypothesis, greater than is alternative.
So depending upon your research objective, it is not always true that null hypothesis will be less than. Because I am trying to find out, my research objective is to find out whether it is greater than certain number. So that's why my null hypothesis will be less than equal to INR 361,975, right? So this is the first step, which is basically 2 marks. You have to write your alternate hypothesis and null hypothesis very clearly. Remember to put equal sign wherever required in your null hypothesis. If you are missing, you lose mark. So like I said, calculation you can do mistake. I do not worry about that. That is normal. But these concept, if you do mistake, you are going to lose mark. So what is my study aim? So what I want to study? What is my objective?
To find out whether the average tuition fee
Average
is
tuition
higher.
fee is higher education is greater than INR
So
360.
the whatever observed, my observed variable, right? So what I am going to observe from my observed variable is greater than some expected number, right? So if it was less than, I would have written less than some expected number, or if it was not equal to, like alternate hypothesis was, just check that whether it is 361,975, right? Then my objective would have been to check whether it is equal to that number or not, right? Simply like, if you look into this 3 statement, it is nothing but I have divided my research objective into 3 statements, right? What is my variable? Which variable I am going to study?
Tuition fees.
Average tuition fee.
So tuition fees is my variable, right? Right. What is my dependent and what is my independent variable?
Sir, this tuition fee is dependent.
Then what is my independent?
Type of higher education?
But I have not mentioned that, right? What kind of higher education have I mentioned? So in the data, if you see higher education,
Sir,
yeah.
will number of students
So
be any,
colleges.
number of students be any in the variable independent dependent number of students, sir?
Where is the number of student? Have you got any? So here only mentioned tuition fees. Have you got that data? So anywhere mentioned number of student, how many number of student? Or like Sardo has mentioned higher education. Yes, it is mentioned for higher education. But have I mentioned whether it is for MTech, MBA, MCA? Is there any category? Okay, these are the first 5 numbers for MBA, other 5 numbers for MCA. If it was there, then yes. So look, how many variables you have? Variables is tuition fees. Right? Yes, exactly. So you have only one variable. So you do not have anything dependent, independent here. Dependent, independent will come when you have multiple variables. I am only studying one variable here. So this is a univariate study. So you write here not applicable. So I ask, that doesn't mean there is answer for it, right? So Ray say that because there is one variable, you need not have to write in that much data, but I am just showing you there is one variable for study, univariate study, right? Then what kind of univariate, right? So this is where, because there are different types. Now last class we had discussed, right? Right tail test, left tail test, two tail test, right? So whenever in your alternative hypothesis, right, there is a greater than symbol. Looking into alternate hypothesis, when there is a greater than symbol in alternative hypothesis, right? Always remember we are focusing on our alternative hypothesis, right? We frame our alternative hypothesis exactly opposite of the null hypothesis. So if there is a greater than symbol in my alternate hypothesis. I know that that is a right tail test. So my data analysis method will be right tailed one sample t-test. So you can say that also jet test, jet why not jet test, that we'll discuss. But right tailed, we know why right tailed, because my alternate hypothesis are the greater than symbol. I want to find out whatever my object variable is greater than certain number which is given to me, right, in my research objective. That's why I want to find out in my right side of this distribution, right? And then one sample, why one sample? Because I'm considering all the data, right, as a one sample, right? So when does that condition of two sample or other samples comes multiple samples? When I consider it, it is not that I'm collecting data multiple times. That we are very clear. We are collecting data once, and that is our cross-sectional study. That is our one sample. But how I am treating them? In this particular case, like Sarda was mentioning, if I have other kind of information, okay, these are the 5 points or 10 points which are for MBA student. These are the points for MCA, balance for MTech, right? So I'm collecting another variable, right? So then I'm considering treating them into 3 samples. What are those samples? One group of students belong to MBA, other group of students belong to MCA, other group of students belong to MTech, right? So in my sample, what I've collected 30 or 29 students, 10 students belong to MBA, 10 students belong to MCA, 9 students belong to MTech. So these are my groups, right? Then I can say that, okay, I'm considering 3 groups or 3 samples. Or if I'm considering, let's say some of them are from engineering and some of them are non-engineering. So I have 2 groups, 2 samples. So when I'm talking about 2 groups or 2 samples, it doesn't mean that I'm collecting data multiple times. I'm collecting data at single point of time, but only point is that how I'm treating them for my study. I'm treating them that, okay, these sample data which I've collected, they are from 2 different groups. One group is from engineering population, other group is from non-engineering population. That is where your 2 sample come. But let's say consider them from MCA, MBA, MCA, MTech. So I'm considering some student from MBA population, some student for MCA population, some other student from MTech population. So I'm considering 3 groups. And that is where you will decide whether you will do ANOVA or some other study. Right? But right now, if you see, I do not have other information. I have only single one variable information about the average tuition fees. This is for each student. So 371,156, you have asked one student's parents. So they have told, yes, on an average, this is the amount. Last year we spent this much amount. Somebody else has told 138,321, right? So this some other parent have told, out of in Odisha you have gone to 30 homes, 29 homes, and you have collected this much information, right? And what was your question? Please mention average amount of tuition fees you have spending for your child's education, right? What kind of scale that question is? If I'm going and asking that single question to all the parents, all those 29 parents, please mention in Indian rupees how much you spend for your child's higher education per annum. What kind of scale is that question?
Metric.
Nominal, ordinal, interval or ratio? Yes, metric. So if out of metric it is interval or ratio. What kind of scale is that? Interval or ratio?
Ratio.
Yeah. Because it has absolute. You are asking about some monetary, right? Money. Most of the times it has absolute zero starting point, right? So why I'm telling you this? This part is important. Go step by step to understand what kind of data analysis you have to do, right? So I'll show you again, like today we'll do it manually. I'll show you. So there is no direct method. Okay. So let me just show you. Just click on the data here on the screen. Click on the data. All of you are getting this data analysis, or all of you
Yes,
are
sir.
present here today.
Yes, sir.
Yes, sir.
Anyone there who is not getting this? Anyone who is not there getting this data analysis? So if it is not there, quickly you can go to File, click on Options. So click on Add-ins. So you can run this Excel add-ins, go. So if this is not checkbox, if it is not highlighted, right? Click that, run OK. Then you should get this option, right? In case some of you do not have this kind of option in your Excel, right? Most of it is already inbuilt, already activated, so don't no need to worry about that. Why am I showing this is that I think you might have used this earlier also. Whatever we are going to do, ANOVA, correlation, covariance, F test, T test, two sample T test, Z test. Z test we are not going to show because T test, Z test almost will give the similar result. Regression, right? So all of this we are going to cover through this data analysis tool, whatever is required for our hypothesis testing, right? So this is very important for us, this option. Okay. But anyhow, today I'll show you just, let's say if you're doing it manually, right? How to do this. So the basic idea is to find out whether this is really feasible. This number is really, so if I say that, okay, if I get this data from my respondents, right? Whether I can make a claim about my population. That is my research objective, right? And I found out that the data analysis method is right-tailed one sample t-test. Anyone having any doubt why you are choosing one sample t-test? So you might say that because we have not covered any other data analysis, this is the only thing we discussed in last class, that's why. But that is not the necessary reason. The steps I showed you, because we are doing a univariate, we have only single variable. So single variable method, at least based on our understanding, we have only know this one, right? T test or a G test, a Z test. So then the question is when to use T test or Z test? Or I will prefer you use T test, why not Z test? So there are two conditions of using Z test rather than T test. Can anybody remind me what were those? Whenever you have this kind of univariate condition, so we can do either a T test or a Z test, right? So distributions are almost equal if you have a sample size greater than 30. But then the question comes when to use Z test, when to use T test. So one kind of normal kind of thumb up rule is whenever you have greater than 30 samples, right? Try to use Z test because Z test and T test distribution will be almost equal. But the problem with Z test is the second condition, no matter what happens, you will not able to get that data. So to use Z test, you should have the understanding of standard deviation or variance of the population, right? But most of the times, like we have discussed, we do not have any information about the population, right? That's why T tests do not have that kind of limitations. Even with the sample standard deviation, we can go ahead. So it is always better to use T test. But can Z test be used? Yes, it can be used whenever your sample size is greater than 30 and you have the understanding of population variation, right? Population standard deviation and population variance, right? So how to kind of go about by like T test, right? One sample T test. First, obviously the easy one, find out your sample average. What is my sample average? So I have this much, how many? 29 data points. So total 29 data point. So this much. This is my average amount which I get, which is from the 29 samples, right? Then I have to calculate something called sample standard deviation. So use this formula stddev.s, that is for your sample. Std standard deviation .s means for sample. So this is my sample average, sample standard deviation. That part you have calculated, right? So this part we have discussed in the last section. And I will discuss this every time almost whenever we discuss two sample data also. There is something called test statistics, right? Test statistics is nothing but your observed value minus expected value divided by standard error. Okay. So the formula of standard error is standard sample standard deviation divided by So this is actually our first step. What we are trying to find out, we are calculating something called test statistics. If you remember, we discussed why we are calculating test statistics, because see, this is for our educational loan, not the higher amount. It is not that your statisticians are going to create a distribution for you. So they have created a standard t distribution or a standard normal distribution. So to use that, we are standardizing the information we have got. What kind of information we have got? We have got these are the data points. So sample average is this. So we are actually standardizing this number so that we can use the existing sampling distribution, existing t distribution. So we are not going to create, like I said, it will be impossible for us to create a sampling distribution, right? So because statisticians have created that table and that is a standardized data. So we are actually standardizing the information we have received. So this is my sample average. That is nothing but when I'm calculating test statistics, I am standardizing that information, right? Anybody having any doubt up to this point? I hope I am clear. So my sample standard deviation is this much divided by square root of my total sample size. If you say I have collected 29 data points, so square root of 29. So standard error is 21276. Okay. So I've got standard error, I've got my observed value, sample average is nothing but my observed value. What is my expected value? Whatever is given in my research objective, 361975. So now I'll calculate my test statistics. Test statistics, my observed value is my sample average minus my expected value is 3. Yes.
Sir, can you show
Please.
again the standard error for me?
1 second. Divided by my standard error. Yes. So standard error is nothing but sample standard deviation, which I have calculated this much, right? Divided by square root of sample size. I have collected a sample data of 29 parents or 29 students. So square root of 29. Okay. Anybody having any doubt in the calculation part?
Can you please show the last test statistics section, sir?
Yeah. So that is nothing but your observed value. Observed value is this much. This is your average. 299474 minus 361975. Why 361975? That number is my expected value, right? My null hypothesis expects that is the whatever the average tuition fees divided by standard error. Test statistics is observed value minus expected value divided by standard error. Standard error is 21276.1. Anybody having any doubt on this? So if you look into this number, sample average is this, right? E14 minus 36197, which is my research expected value, divided by F21, that is my standard error. Anyone who is not getting this number, minus 2.93. So I found out my test statistics. Next is my critical value, right? To find out critical value, I need two information. One is decrease of freedom Second is my, what else is required to find out critical value?
Alpha.
Alpha, right? So alpha, if you remember, it was given, consider alpha is 5%. If it's not given also, you can take 5%. If you want to take something else, please do mention that in your paper, right? 5%. Decrease of freedom will be what much? Decrease of freedom is sample size minus 1. So 29 minus 1, 28. 5% is 0.05. So to find out critical value, I always need which kind of hypothesis testing I am carrying out. To find out critical value, I need always two information, alpha and degrees of freedom. Alpha value almost most of the times it will be 5% unless otherwise mentioned. Degrees of freedom depending upon what kind of test you are carrying out, right? I'll show you different formulas. So that is something again you have to kind of practice. So in the sample t test case, it is very simple, sample size minus 1. So I have 29 sample data points, minus 1 is 28, right? So I calculated something called test statistics. I calculated something called critical value. No, I have not calculated. I have just shown you degrees of freedom and alpha, right? So this table will be given to you. Students t distribution table will be given to you in your exam, right? So what you have right now, I have to find out what is your alpha, 5% 0.05. Then degrees of freedom is 28. So what is your critical value? 1.701. If you go to the t distribution tab in the Excel file, go to the alpha value of 0.05, degrees of freedom at 28, you will find the value of 1.701. Anybody having issue with that, getting that number? Okay. At alpha 0.05, degrees of freedom 28, critical value is 1.701, right? So for a how to carry out the hypothesis testing, only thing is you have to compare whatever test statistics value you have received. So visually, if I want to show this, right? This is not required, but let's say, so for your exam point of view, you need not have to kind of create this thing. But only thing I want to explain this little better. So what it shows that where is my critical value? Critical value, if my null hypothesis was true, that is my range. All my sample data points will lie between them, right? So okay. So if you just want to see visually, this is my sampling distribution for the data sample I have collected. If I convert that test statistics to a standardized value, it is lying here minus 2.93. It is very close to minus 3, right? But if my null hypothesis was true, when I'm saying that, okay, where is this? Find out average tuition fees in India for higher education is greater than 361,975, right? If this null hypothesis was true, then anything beyond that 1.7 number. So we remember what we said in hypothesis testing. We start with the belief that null hypothesis was true, right? If null hypothesis was true, this number, what is that number? 361,975. If the average tuition fees was 361,975, the data would have been inside this. Data would not have crossed that, right? In my case, what happened? I got a number of minus 2.93. It is lying here within that range, right? Because if null hypothesis was not true, what would have happened? I would have got a number of any number greater than 1.7. If I would have got a number of 1.8 or 1.9, so what would have happened? The test statistics would have been in the right side of this, right? Then I would have told that yes, in my right tail test, my test statistics was greater than. So when you say in a number line something is greater than something, what would have happened? This line, this number would have been the right side, right? So that is the definition in a number line, how we write down our number. Negative, then 0 in the center, then positive in the right side. Height is greater than 3. How we get that? So if you remember in the class 1 or in the class 2, when they taught us the number line. So we put a number line, say that 1, 2, 3, 4, 5. Height is in the right side of 3. That's why height is greater than 3, right? But if you see here in the number line, what is happening? My critical value, the boundary of null hypothesis is being true, is 1.7. So if I put that in my number line, it will be here. If I would have got a test statistic, let's say 1.8, then what I would have told? My test statistics, I'm getting a number which is greater than my critical value. That means my null hypothesis might not be true. With 95% confidence, I'm telling that my null hypothesis is not true. But in this particular case, what happened? It is within that range. It is left side of this critical value. It is within that range of 1.7. My test statistics, I got a number of minus 2.93. Then what will be my answer?
We will accept the null hypothesis.
So we do not say that we'll accept. We'll say that with 95, with the information available, we cannot reject the null hypothesis. Generally, in research methodology, we do not say that we are accepting. That is given. We say that we cannot reject the null hypothesis. That was our objective, right? We wanted to reject the null hypothesis, but we could not reject the null hypothesis, right? So, for your exam point of view, do not copy the raw data. Whatever you are writing, mentioning here, everything you have to put in your, write down in your copy, in your exam copy, right? Any question, any doubt on this? So I'll be much more focused on this part of the data, how you find out or how you logically arrive in the conclusion that it is a right tail one sample t-test, right? So once you do that, the steps are find out your test statistics, find out your critical value, right? Then compare test statistics with your critical value. Then if your test statistics is in the right side of your critical value, right? If let's say I have got a number of 1.8 test statistics or 2 as test statistics, it would have been in the right side of your critical value, then I would have rejected, right?
Sir,
Yes.
sorry, आप समझ नहीं आ रहा। ये शेडेड एरिया यहाँ से यहाँ पे थी, मैं राइट पे उससे राइट साइड में शेड होना चाहिए ना?
But it is not there, right? So that is my objective. But minus 2, do you think that in a number line minus 2.93 will be in the right side of 1.7? So this is a number line, right?
Yeah.
Minus 3, minus 2, minus 1. So where is my critical value? 1.7 here, right? Where is my test statistics? If so, my objective is to find a test statistics which is greater than my critical value. But what test statistics I got? Minus 2.94, which is in the left side. So I will not be able to reject the null hypothesis. So the idea is to reject null hypothesis. If I would have got a test statistics, let's say 3 or 3.5 or 2.1, then it would have been in the right side. But in this case, is it there? It is in the left side, right? Then I will not able to reject the null hypothesis.
Sir, in the graph, sir, what is the blue marked area? Why is it marked, sir?
Yes, sir.
No, that is not required. So I have just taken it. That is not at all. Okay, trick question. If the alternate hypothesis was less than, let's say they want to understand whether it is less than INR 361975, then what would have been my result? If my alternate hypothesis was less than 361975, in that case, what would have been null hypothesis? Greater than equal to 361975. Right? Then what would have I done? Right? So because steps remain same, calculation, everything remains same. This for the left tail test also same formula. There is no change in the calculation. Critical value, you get something like this. Only changes in how do you consider your critical value. And how do you compare? So remember, this step is very clear. It was a right tail test. This was our conclusion. What I'm asking, if that was a left tail test, and my objective was to find out if average tuition fees is less than 361975, and the data remains same, right? Then calculation also remains same, right? There is no change in data, and there is no change in calculation. Then what would have happened? What would have happened to my result? Whether the result would have remained same, or is there any change?
So if the calculated value would have been more than the critical
No,
value,
calculation remains same, right? Calculation remains same. There is no change in data, means the steps remain same. Only thing is that in this case, right tail test I would have written, this is a left tail test.
okay.
So the
we
test
should have
statistics.
rejected the null hypothesis.
Why do you think so? What would have been happened to critical value?
So,
The critical value would it have been 1.7 or something else?
same. Okay, minus 1.7.
Yes, because we are looking into negative side, left side of the distribution. Anything left side of 0 will be in the minus part, right? So critical value, you'll go to the table, you'll find out. That is, if you go and see in the T distribution, it is written here. Table of the student T distribution table gives the value where this is with whatever this lambda is the degrees of freedom. But this is a right tail. This is only given for the right side of the data, right? These numbers, what you are getting, they are the positive numbers. 0, the center point, mean point is the 0. Anything in the left side will become the mirror image of that with a negative sign, right? Same number, but what would have told? My critical value is no longer plus 1.7, it is minus 1.7, right? Because what I'm trying to find out, if this is less than INR 361975, right? I got this number as minus 2.94. I want to check that whether it is below the range of critical value, right? In the other case, what I was trying to do, is it above the range of critical value? Calculation remains same. Here, what would have happened? My critical value would have been the left side of the distribution. Left side of the distribution means negative value, minus 1.7. Same value. Value is not changing because my degrees of freedom remains same. 29 data points, 29 minus 1 is 28. Alpha value remains same. There is no change. Only change in the direction. In the right tail test, I was looking at the right side of distribution. When I say right side of the distribution, right side of 0, right? 0 is the middle point, 0 is the mean. Right side of 0, that is the positive number. Left side of 0 is the negative number. When I'm looking to left tail test, right? I look into the left end of the distribution. So my critical value would become mirror image of whatever I got in the right tail test. So that was 1.7, here minus 1.7, right? Then my test statistics, the calculation remains same. I've got minus 2.94, right? Then what would have happened? With this, if this was I was doing for a left tail test, my objective was to find out average tuition fees is less than 361975, and I had got this number. Then what would have happened?
So reject
Whether
the
I would
null
have-
hypothesis.
Yeah, because it is below the range of the critical value, right? When a left tail test, if it is below the range of my critical value, I reject, right? Minus 2.94 is less than minus 1.7. That's why I'm rejecting. In the right tail test, if it is above the range of critical value, then I reject, right? So clear or any doubt?
So the last point you made that it is less than we reject. Sir, can you explain it one more time?
Yes. So in the right tail test, what exactly you did? You found out critical value is 1.7. that is positive side. Then test statistics was minus 2.94. There is no change in critical test statistics. So you said because I am carrying out a right tail test, if I would have found a test statistics which is greater than critical value, I would have rejected. But I got a test statistics which is a value of minus 2.94, which is less than critical value. Then I would not be able to reject null hypothesis. Then that's it. Now what happened? I told you change your null hypothesis, change your alternate hypothesis. Say that rather than trying to find out whether it is greater than 361975, you are trying to find out whether it is less than 361975, right? Then what would have happened? Then your test statistics calculation remains the only thing what changes whenever we are doing a left tail test. So we are looking into the left side of the distribution, left side of 0, right? So in that case, critical value changes the direction, changes the number doesn't change. The direction, positive or negative changes, right? Because we are looking something in the left side of the 0. The critical value will become rather than plus 1.7, because we are looking into the left side of 0, that number will become minus 1.7. Now my test statistics, any of that calculation remains same. So now I will try to find out whether my test statistics is the left side of critical value. So when I say left side is less than my critical value. So if my test statistics is in the left side of critical value, or test statistics is less than my critical value in a left tail test, then I reject null hypothesis, right? So in that case, what would have my insight would have been, with the information available with 95% confidence, the null hypothesis was rejected. That means yes, the data point what I have collected, it shows that the average amount of money parents spend is less than 361975 for the population. Right? Okay. So do one thing, I have given you another average ATM usage, same step, follow that. So next class when you come, we'll discuss this example, see that whether you are doing it correctly or not. Follow the same method, follow the same approach, right? So this is for your kind of a practice. So before we have another 7-8 minutes, I just want to show that how to use this confidence interval, right? Right now elections happened, right? And most of the polls, they showed that, okay, one company or one political party will win this many seats, right? How do they do that? So it is not that they're going and asking all the voters. They'll go and ask randomly, let's say in a state, 5,000 or 10,000, like those people who are going to vote, they'll ask that which party will give vote, right? Probable party which will give, right? So like that, I've collected data across different districts in Odisha. One district, the overall kind of number I got, average number I got, 49 like respondents are going to vote for that party. Another district 125. Like that, I've got this much, how many? 20 different districts I have collected data. Right? Now I have to go and in a TV show I have to tell that what is the range, right? How will I calculate that? Here there is no hypothesis, right? Here they just want to predict for a party with certain accuracy that okay, how much seats that party is going to win, right? So it is different than hypothesis testing. In hypothesis testing, what it whether the party will win greater than 100 or less than 50, like that we can test. Here, my like TV program asks me to tell me that range within which the party will win, right? On the number of seats the party will win, right? Steps remain same. First, we have to find out this average, right? What is my average? Sample average is average of this number. So n is actually 20, number of sample is 20. I have collected 20 data points. So what else I need? I need critical value, right? Critical value depends upon confidence level. I have told alpha is 5%, right? So what is my critical value? My degrees of freedom, what is my degrees of freedom?
19,
19, sir.
19.
This is 0.05. So I go to this T distribution at 0.05, go to 19, I find 1.729. That's a 1.73. Critical value I found out was 1.73. So this part is I got this number also. I got 81.4. I need standard deviation. So I go to that formula. Standard deviation is 46.23. So if you remember, this is nothing but your standard error which you are calculating in the what will be my standard error. Whatever is my standard deviation divided by square root of sample size. I have 20 data points. 10.33. Right. So this margin of error is my TC, that is my critical value 1.73 multiplied by my standard error. Right. So if you look into this formula, my critical value multiplied by standard error. I did the same thing, right? 17.9. Right. So what is my upper limit? Whatever is my mean value plus my error 99.3. What will be my lower limit? Whatever is my mean value 18.4 minus error 63.5. So if I go to the TV show, what will say if I've collected data this like randomly? So this party, so I have 95% confidence on my study. So I'm not 100% sure. Like with 95% confidence from this study, the party will win how many? Between 64 to 100 seats. Right. So this is where your confidence interval. So this is my confidence interval. So I know that any number between the population, if I actually collected data from all the people who are going to vote, I would have got a result that this party will win somewhere between 64 to 100 seats. Right. This is where your confidence interval. Confidence interval says that okay, where does your population mean will lie? If I had collected all the data, my 95% is guarantee that this total number of seats which this party will win remain between 64 to 100 seats, right? And to find out this confidence interval, I need critical value. For critical value, I need this alpha or the confidence level, right? That is where your confidence level and confidence interval are related, right? So whenever you want to find out a range within which your population mean will lie, then only we use confidence interval, right? And for our hypothesis testing, which I showed you, confidence level is required. Clear or any doubt? Okay. So please do practice this, at least this average 18 usage. I have given you a research objective, go step by step, carry out the calculation, and next class we'll discuss whether you have done it correctly or not. Then we'll jump into two sample t-test, right? Any questions, any doubt before we close out for today? Okay. If not, take care. We'll meet next class and go through the two sample t-test. Chalo, bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.